a force is applied at an angle, let's say a 5 Newton force is applied at an angle of 15 degrees. The mass of the box is equal to 10 kilograms. Okay? I want to know what the y and x components of the force are and what the normal force, gravity, and acceleration are for this whole thing. And you know what? Let's go ahead and move this over. Okay, so drawing these things in, you know we're going to have a normal force and a gravity force. Let's say mass is 10 kg, theta is 15 degrees. I want to know Fn, Fg, Fx, Fy. Ran off the edge. And acceleration. Okay? So, and if I'm still at 0 at the end of this, we're going to go ahead and stop. Okay? So, now just like we did with vector addition, we need to add up everything in the x and y directions. We have everything drawn into our free body diagram right here. We have Fg, Fn, and we have our applied force. This would usually be called Fa, but we're going to split it into Fx and Fy, as you can see down here. Now, our x's only correspond to the x component of this force right here. So this would be 5 newtons times the cosine of 15 degrees. But our y is equal to, we have the Fn, we have Fg, and we have the y component of this force, which again would be 5 sine of 15. Okay, so we have more stuff going on in the y than we do in the x. Now, the easiest one to probably calculate is this Fg right here, which is equal to ma, which is 10 kilograms multiplied by 9.8 meters per second squared, negative 9.8 meters per second squared, or negative 98 newtons. Okay, negative 98 newtons. This one right here, 5 sine of 15, is pretty easy to calculate too. 5 sine of 15. Let's make sure. Mode, okay, good, I'm in degree mode. So 5 times the sine of 15 is 1.29 newtons. So that's our Fy, 1.29 newtons, and it's pointed up, so we're going to leave that as positive. Fn, as I've mentioned before, we can't calculate directly, but let's go ahead and calculate our Fx, which is just going to be 5 times the cosine of 15, or 4.83 newtons. Okay? Excellent. Now, let's start with the Fy, just because I want to finish on the acceleration. So let's go ahead. So sum of forces in y equals our mass times our acceleration. Now, we were not told that there was any acceleration or any change in velocity upwards in the y direction. And frankly, since I'm writing the problem, I'm going to go ahead and tell you that there is none. Okay? So our acceleration is going to be 0. So all of our forces added together must equal 0. Okay? They're all balanced out. And that includes our normal force plus our force of y and plus our Fg. Now we already know Fy and Fg, so we can plug in our numbers. Fn equals negative Fy minus Fg, or negative 1.29 minus a negative 98. So 98 minus That gives us a normal force of 96.7 newtons. Okay? Normal force of 96.7 newtons. 96.7 newtons. That's what it takes to balance out everything in this problem. And then lastly, super easy, our forces in x are equal to our mass times our acceleration in x. And again, we only have the 1, which is 4.83 newtons, equals our mass of 10 kilograms multiplied by our acceleration. Divide both sides by 10. And we end up with an acceleration of 0.483 meters per second squared. Boom, there we go. Excellent.